Going on to topic 2 of chapter 5 as we move along. We're going to look at polynomial functions and adding and subtracting polynomials. We want to define a polynomial, a monomial, a binomial, a trinomial, and degree. We want to define a polynomial function, simplifying them by combining like terms. We did some of this in chapter 2, and then add and subtract polynomials. Okay. Well, first to take a look at these terms here. Something is a monomial if it's one term, a binomial if it's two terms, a trinomial if it's three terms, and then all of the others are poly. Now these are called polynomials too, but they have the extra name. Now we said we separate terms by either a plus or a minus sign. So this would be one term, two terms, three terms, four terms. This would be a polynomial. So what do we have here? This is a trinomial. Three terms. I here, yep. This is a bi, two terms. This is a mono, one term, and this is a binomial, two terms. Again, there's no plus or minuses in here, so one term, one plus, a plus and a minus. Okay. Now, degree of a term. We say a degree of a term would be like 3a to the second plus 4a squared, a cubed, let's make that b to the second. So two terms, and the degree relates to the sum of the exponents on the variable. So here this term has just 2, a degree of 2, because it just has two exponents. This one has a 3 and a 2, so the sum of them, the degree of this term is 5. So keep in mind we could put little ones here. The degree of this one is 2. This is 1. This is 2. This is 3. This is 1. If there's no variable, it's a 0. Again, there's a 1 there. This is 4. This is 4. There's a 1 there. This is 4. Now this is a 5 and a 2, so it's 7. 4 and a 1, that's 5. A 1 and a 1, that's 2. So we now have listed the degree of each term, but now we want to find the degree of the polynomial. Well, that is determined by the largest individual degree of the term. So here we have a 2, a 1, and a 2, so the largest is a 2. So the degree of this polynomial is a 2. This one, the largest, is a 3. So the degree of that is a 3. Here these are all 4, so the degree of this is 4. Here the largest degree of any individual term is 7. That happens to be the degree of the polynomial. Now here they want you to evaluate a polynomial with -2 replacing the letter. Okay, so let's just set this up. 4 times -2. Well, actually they want us to do, I guess, two parts. a 0 first, then a negative 2. So this would be a 0 minus 7, that's for 1, and then 4 times the other, negative 2 minus 7. We'll just set them up here. This is going to be 0 to the third minus 4, and then negative 2 to the third minus 4. And this one for a 0 and a 0, these are both going to be 0. So the first one is just a negative 9. And then for the others, 3, and then a negative 2 squared plus 8 times negative 2 and a negative 9. And here this is going to be a negative 13 minus, well, this is going to be a 0 and this is going to be a 0. So this is, the first one is just going to be a negative 13. And then when we put a negative 2 in there, let's do it. That one is negative 13 here for the first one. Then this one, negative 13 minus 4 times negative 2 minus negative 2 squared. Okay, we've done the substitution of these now. So for this one, it's just going to be a negative 7. Here, this is a negative 8, and a negative 7 is a negative 15. This is going to be just a negative 4. And this will be a negative 8, because it's negative 2 times negative 2 times negative 2, odd, negative 8, negative 4, negative 12. And this one's going to be a positive 4, so 3 times 4. This will be a negative 16 and a negative 9. So a negative 16 and a negative 9 is a negative 25. So 12 minus 25, I believe, is a negative 13 there. And then here we have a negative 13. This is going to be a positive 8. Now inside here, this becomes a positive 4, but that's a negative 4. So we have a negative 17 plus 8, a negative 9. Okay, so we did all of number 2 through substitution using function notation. All right, let's raise it up a little bit. For number 3, they want us to simplify each expression by combining like terms. Now, a like term by definition is 2a and 3a. These would be like terms because the variable is exactly the same, to the same power. So here, these are like terms. Now, when we add or subtract like terms, we just deal with the numerical coefficient. The variable doesn't change at all. Some people lost points because they were changing them. They don't change when we're adding or subtracting. So this one would just be 5a. This is going to be a negative 10 and a 3, a negative 7x. Now here we have to figure out what are our like terms. Well, this is a like term. This is a like term. And then we have this one's a like term, and this one's a like term. Now on your test, what would be a good technique? Again, on your test, you want to be super careful to make good choices. On your test, a technique to do this would be put the like terms in like term columns. This is a like term, and this is a like term. This is a like term, and this is a like term. Now, this one was so easy, you could probably do it horizontally. But again, on a test, this is a critical question. You want a strategy that, gives you a great accuracy. So now we're just adding up our numerical coefficients. This is going to be a negative 2. Y to the thirds don't change. Now here, this is going to be a negative 4, x to the second. Now for letter C, this looks kind of tedious, and it is. But again, you want to identify the like terms. I have a 3.7x to the third. Then I have here a negative 1.0 x to the third. These are my like terms. Now any others? Well, yes, I have a negative 6.3x, and I have a 1.8x. Then I have here an 11.6, which is a plus, and a negative 8.2. Theoretically, you can add them up separately if you want. So this one is going to be 2.7x to the third. Now this we know is going to be a negative because the negative is the larger absolute value. We're going to borrow one. This is going to become a 5. This is a 13 now. That becomes a 5x. 1 from 5 is 4. You're going to use your calculator, I'm sure. And then here, this is going to be a plus. This is going to be a 4. And this is going to be a 3. And we can just check it out right down here. Perfect. All right, now we're asked to perform the indicated operation. So what is this? This is addition. So we're just going to put these in like term columns. Now again, you can do this mentally. They're both going to be positive. Now this is going to be a negative 3 and a negative 7. So this adds up to 6x minus 10. Now you can do that mentally. This one was real easy, but I'm trying to show you a technique that really ensures getting it right. All right, this one is going to be critical. I'm going to write the top one. 5x squared plus 3x minus 7. Now notice it has a negative sign there. We had said when you have a negative before a parenthesis, take away the parenthesis and just change these signs. So this is going to become a plus 5x. This is going to become a plus 3. So now we're no longer subtracting, we're adding. And sometimes it's unlike sign numbers. But the process of subtracting was to change these signs, which we did, and now we just add. So 5x squared plus 8x minus 4. Ah, perfect. Again, I saw a lot of these incorrect. They didn't have a strategy that would give them correct answers. Now, here's kind of a tricky one. When it says from something, put this on top. 5x minus 7y. Now they're saying subtract this. Well, think of this as just being a negative sign in front of that parenthesis. What did we do over here? we changed both signs, and then we added. So this becomes 2x minus 9y. You want to do something so you get the correct answer by practicing a good strategy, a good technique. You develop accuracy. That leads to mastery. Okay, this was a short lesson.